Welcome to another exciting episode or installment of the Container Academy, our Container as a Service Academy. And today we're going to be talking about build management. So, why are we talking about build management? One of the reasons you're deploying a Container as a Service environment is you want to probably deploy code faster, more agilely, and as microservices versus big monolithic components. That all means that you're going to be committing code more frequently, and you're going to be wanting to iterate on those more rapidly. So you really want a process that will, as much as possible, or as much as your process is going to allow you to rapidly push something from code through to build, to test, deploy, and out the door. And we'll talk about deployment management in another episode. But let's talk about build management. So most folks today going in a container environment will be using some kind of software version control system. The most common by far is a Git-based system, be it GitHub, GitLab, Bitbucket, etc. And there's commercial variants of those, etc. as well. But you're checking your code usually into Git. The way Git works is as a general rule, you can have multiple branches of a code base. So, the code, let's call this master, and there's other ways of doing this. And there's many, many different ways of doing your Git modeling, how you model the use of branches, etc., tags, releases. They all have their good points. They all have their bad points. They're all very religious. I'm not going to talk about them in general, but I've got just go off of the very basic. I've got my master code line here, and every once in a while a developer will take a branch off, and then she starts writing code and committing into it as well. And another developer takes something off of her work, and he starts building as well. And you've got another developer that takes off of another branch here, and they start building. And all of these are separate branches. As they're going, you probably want to be doing some kind of testing just to make sure this all works. Or maybe you've got, this is a candidate branch and there's master somewhere else. But again, basic master branch. At some point, all these developers are going to want to get their work back in. So, this process has gone on. At some point, this orange developer is going to want to do what's called a pull request and merge their code back into the purple developer's her branch, because that's where he pulled it from. And this green developer is similarly going to eventually want to commit their code back in. And she's still chugging along, writing lots of code, and then some point later, she merges back in. Depending on where you want to do it, you may decide you want to do builds across all of these branches. Or developers might decide they want to do a build on these branches because they want to see if they've broken anything. You certainly probably want to do builds whenever somebody commits to your candidate or your master or whatever scheme you're using. So all along this way, we're doing commits. At least here, maybe more places. What you can do is at each commit, you can set a hook, usually a webhook of some kind. Maybe this is all integrated. If you're using GitLab, they've got a CI process built in, but there's lots of CI processes out there, and they all integrate to everyone, so pretty easy. But you have a hook that basically says, there's been a commit to the master branch, here's the commit. So that gets sent as a message, a commit message, to some kind of CI system. Continuous integration system. In these repos, there will be some kind of config file. So sitting in each, in this piece of code, in this repo, somewhere in here, there will be a CI config YAML file or something along those lines. And that's part of this branch or this repo. That will get consumed when the CI tool gets the commit message. It is going to go and pull a copy of this repo. So the CI tool will fire off a worker. That also might be a pod in Kubernetes or a container. It might be dedicated VMs. But this CI is going to assign some resources, and it is going to pull this commit, the image associated with this commit. It's going to feed it to that worker and set that worker up based on this CI config. And this is a Python piece of code. This version of Python needs to be included, et cetera, et cetera. And the CI will then hand this off, hand all this off, the config and the code to a worker or a worker farm. And the worker will then go do building, checks, etc., and return back the result to the CI process. Built correctly, functional test passed, or built, functional test failed, or there's some piece of code in there that requires sign off. It hasn't been through code review yet. Maybe you require 2 code reviews. There's only 1. So the CI process says not ready. And then the CI process then goes back to, actually I should have drawn this differently. This commit, this message actually isn't really coming out of here. This is coming out of my source code repository. So the source code repository, i.e. your Git, or you're accessing Git, sends this information to the CI, and the return comes back here. And then you get an email message saying your build succeeded, or your Slack, you get a Slack saying your build succeeded, or you get a message that something failed, or you need to do another code review, etc. This is build management. Next time you get a check into master, guess what? The CI runs again, and he just keeps on doing this. The CI config usually says what branches should be picked up by the CI. Do you want to pick up master, or do you want to pick up development branches as well? So maybe on each of these commits, you're also running this as well. Maybe on development branch, you may not run all the same tests you do as on the master branch. But this is build management. So the idea here is all of the testing, the build is automated. It's something the developers don't need to manually do. Both, it offloads the developers so they can spend time working. They can now keep working on code while they're waiting for the build system to work. Secondly, it means that all the processes and steps are done in order. None of them are missed by accident because it's not a manual process. It's now automated based on the CI system, the source code repository system, and the config that's sitting actually in the repo itself. That's an introduction to build management. Sometimes your orchestration system may provide you with one of these. Sometimes your SCR system might provide you with one of these. Source code repository system may provide you with one of these, or you might hook this up yourself. But this is build management, otherwise known as continuous integration. I hope that at least explains it a bit, and we'll explain it in more detail right after this.